Hello, we are CDTR Design and Engineering. We are very excited to present our final designs for our Nampa Parks and Recreation Infrastructure Development Project. Our team has been working on the design since January, and we are very excited to share our final design. First, I would like to introduce the team. Tristan Sellers is our transportation engineer. She has gained modeling experience through internships with the Army Corps of Engineers and Department of Agriculture. Declan Whitworth is our hydraulics engineer. He gained experience in using the HEGRAS modeling system from the hydraulics course provided by the BSU College of Engineering and has experience in MATLAB and other coding languages. The structural engineer of the team is Connor Asmus. His experience working at Tamarack Grove Engineering has given him the knowledge in structural engineering to be able to accurately analyze the elements of this project. And Riley Bangs is the geotechnical engineer for this project. By taking properties of soils and communicating with geotechnical mentors, she has gained many technical skills for soil analysis. The goal of this project is to transform a plot of land in Nampa that was once used as a meat packaging plant into a public park.
Thank you, Declan, for that introduction. So as he mentioned, my name is Tristan Sellers and I'm the transportation engineer for this project. So I'm going to go over a little bit of our site overview with our 3D rendering model, and I'll just kind of explain some things as we go. So as vehicles approach, they have the decision to either follow the road turning left or they can go right entering the park. I would like to note the speed limit changes from 25 for the curve to 20 miles per hour, just because of the pedestrians and bikes we'll have on this path right here. So their first traffic control sign is really the stop sign right here. And that's because we were told to design a one-lane bridge, but it needed to be able to withstand two-way traffic. So this stop sign is where they will be able to make that decision of whether or not it's safe for them to go. You can kind of see out in the distance over here, that's where the other stop sign is. Just because of the model and the program we're using, you can't really see it, but there is plenty of distance for drivers to be able to make that decision safely. Once they see that it's safe for them to go, they will be able to move on and cross the bridge. There is a pedestrian crossing sign over there just to warn them, because this is a parking lot, so people will be walking to and from their cars. So as they enter the park, it's a one-way parking lot, kind of in a roundabout shape, and that's just to help with the flow and to prevent blockage at the mouth of the bridge. So as vehicles go around the parking lot, there's plenty of parking spaces for them. There's a sundial in the middle for them to go to, and then they keep going, and then there's another stop sign. This is the one I pointed to just a second ago from the other side. So this is where vehicles will stop right before they leave, and they'll make that decision of whether or not it's safe for them to go based on any oncoming traffic. Once they make that decision, they're free to cross the bridge, and then they will lead them to their final stop sign when they're leaving the park. And this is where they will make the decision of whether or not it's safe for them to re-enter traffic. This is a two-way lane, so they can turn left or right. And as they leave, the speed limit does jump back up to 35 miles per hour because there's no turns and they are leaving the park vicinity. One quick thing I'd like to point out just before exiting the model is here's where our water storage tank is. Connor will go over a little bit more detail in a second after he discusses the bridge though. Thank you for your time.
All right, I will now discuss a little bit about the bridge that we have designed. The bridge model that you see in front of you was created using RISA 3D, which is a structural engineering software that can be used to model and analyze various structures and their structural components. We decided to go with a rather simple bridge design in order to not distract from the natural aesthetic of the surrounding park area. This bridge was designed to allow pedestrians as well as large emergency vehicles to cross over it with ease. There will be a barrier between the roadway and pedestrian walkway to ensure the safety and comfort of pedestrians. The bridge was designed using square HSS members, which are square-shaped tubes of steel that range from 5 inches wide to 9 inches wide. We have also used the same square tubing to support the concrete roadbed that will lay out the roadway for our bridge. After deciding the layout for our bridge, our team recreated our vision on RISA and designed the model that you see. Loads were applied to the model as required by local and national code requirements to ensure the members would not fail and cause harm to those crossing it. After some tinkering with the member sizes to ensure no failures were occurring, the final bridge design was determined. From this model, details of the members and their connections to each other can be created that will be used on the construction site to build the bridge. Here are a couple of details that our team created to show how the construction of our 10,000-gallon reinforced concrete tank would happen. These are fairly typical looking details that you would see in the industry that an engineer would create to design a reinforced concrete structure. As you can see, the details show the size, number, and spacing of the reinforcement, as well as show various dimensions of the tank. These details would be used on the job site by the construction crew to determine what to do to properly build the tank according to the engineer's calculations and requirements. Thank you so much for watching our presentation. We hope you enjoyed it.